Before configuring a web application firewall, it's important to understand how traffic flows through an F5 BIG-IP device. Every client sends traffic to a public IP address, known as the virtual server or VIP. The virtual server receives the request and forwards it to a pool, which contains one or more backend web servers called pool members. Depending on the load balancing method, one of these servers processes the request. If Source Network Address Translation, or SNAT, is enabled, the F5 changes the client's source IP to one of its own self-IP addresses, ensuring that the response returns through the F5. This traffic flow forms the foundation of every F5 deployment. F5 BIG-IP uses several core components that work together. A virtual server is similar to a listener on a cloud load balancer. A pool groups multiple backend servers, while pool members represent the individual web servers. Health monitors continuously check whether each server is healthy before sending traffic. Finally, SNAT changes the client source address when required, ensuring that response traffic follows the correct network path. Let's follow a real packet. The client connects to the public virtual server IP. F5 receives the request and selects a healthy pool member using the configured load balancing algorithm. Before forwarding the packet, F5 may perform SNAT, replacing the original client IP with one of its self-IP addresses. The backend server processes the request and sends the response back to the F5, which restores the original client information and forwards the response to the client. This symmetric traffic flow is essential for proper load balancing and application delivery. SNAT is one of the most commonly misunderstood concepts in F5 deployments. Without SNAT, backend servers may send responses directly to the client through a different gateway, creating asymmetric routing and causing connection failures. With SNAT enabled, servers always return traffic to the F5 first, allowing it to maintain the full client session and forward responses correctly. In many enterprise deployments, SNAT is a critical configuration for reliable application delivery. Now that we've covered the core concepts, it's time to move into the hands-on demonstration. We'll create a pool, add backend web servers, configure a virtual server, attach the pool, enable SNAT, test the application from a client, and verify the packet flow using tcpdump from the F5 command line. We have launched in AWS Cloud 2 instances, F5 WAF and Test Web Backend Server. We'll begin by creating a pool named Web Pool. A pool is simply a collection of backend servers that will process incoming requests. Each server is added as a pool member, and an HTTP health monitor ensures that only healthy servers receive traffic. Next, we'll create a virtual server. This virtual server listens on the public IP address and port 80 for incoming HTTP requests. We associate it with the web pool and enable SNAT using AutoMap, allowing the F5 to translate the client source address and maintain symmetric traffic flow. The configuration is now complete. When we browse to the virtual server's public IP address, the F5 distributes incoming requests across the available backend servers. Refreshing the page demonstrates the configured load balancing algorithm as traffic is shared among healthy pool members. Finally, let's verify everything from the command line. The tmsh commands display the virtual server configuration, pool details, and the health status of each backend server. We then used tcpdump to capture live packets on the F5. Notice that traffic arrives at the virtual server and is forwarded to the selected pool member. If SNAT is enabled, you'll observe the F5 self IP as the source address seen by the backend server, confirming that traffic is flowing exactly as designed. In this episode, we've learned the essential building blocks of an F5 BIG-IP deployment: virtual servers, pools, pool members, health monitors, SNAT, and packet flow verification. These concepts form the foundation for everything that follows in this series. In the next episode, we'll configure our first F5 Advanced WAF policy and see how it protects applications against real-world web attacks. Hope you have enjoyed the video and demo. Please like and subscribe to our channel.